Assalamu alaikum. In this lecture, I will discuss about the inequality and especially about the absolute inequalities. And before going toward inequalities, we will absolute inequalities. I will discuss a bit about intervals because each time when we solve the inequality or equation, we need to represent the solution or we need to find the solution in the form of interval. So what do we mean by intervals here? So we have already discussed the definition of the interval, that what is the notion for the closed interval. So here you can see that closed interval is actually a line segment of the real line. It's a part of a real line or the number line. And for the close interval, we use these square brackets, and for the open interval, we use the parentheses, these round brackets we use. And I hope this is already clear. And now here we will discuss a bit about the types of intervals. So here you can see that we have different notions for the intervals. Here we have two types of interval actually. So one, the finite interval. Now what do we mean by finite interval? Finite interval is an interval when we know both starting and ending point of the interval. So if both are known, starting point, that is called the lower bound, or the upper bound, the ending point of the interval. So all those intervals are finite interval. Now it doesn't matter that either they are open or the close interval. Here you can see that this is the open interval. On both end we use the round bracket over here. This means this A, the starting point, and the ending B, these are not included in the interval here. And how in description form we can write it, that x such that x is strictly less than b and x is greater than, strictly greater than a. So this means all those x numbers from the real line which lies between a and b, those will be included in this interval. So if we use strictly less than sign over here or strictly greater than sign, then we will use the we will not fill the circle over here, and we will not use the close bracket, we will use the round bracket if we are considering the open interval. So this is a finite interval, but this type of interval is called the open interval because here the starting and ending point not included in the interval. Here we will use strictly less than sign, and also we will not fill up the circle over here when we will represent this interval over the number line. Now here we have the close interval. This time we are using the close brackets. These are the square brackets, and here we will now use less than or equal to. So all those number which lies in between here a and b, those will be the all those will be the member of this interval. So here this time, because here we have the equality, here we have the square bracket, so here we will fill up the circle. This means that starting and ending points are also included in this interval. And now here we have the semi closed interval or half open interval, you can say. It is now closed from the starting points from the left side, and it is closed from the right side or the ending point. This means this A is included in the interval, but B is not included in the interval. So if A is included, we will use this inequality over here, less than or equal. And if Here we are using the open bracket over here, the round bracket. This means b itself is not included in the interval. So we will use strictly less than. X will be, the solution will be strictly less than this b. And similarly, we can write here at the ending point b, and we will not fill up the circle over here. This means this b is not included in this interval. Rest of all the points in between a, including a, are the members of this interval. Because here on the number line we have lots of numbers, lots of number, either they are natural, whole number, rational, all those numbers lie on these number lines. So we have many member in between them. Similarly, here we have, this is the half open interval, or you can say the semi-closed interval. So here this a point this time is not included in the interval. So here we will use strictly less than, and here we will not fill up the circle over here. This means this a is not part of the interval over here. So all these are the finite interval where we know the starting and ending point, lower bound or the upper bound of the interval we know. So these will be finite. But whenever we don't know the one of them, starting or ending point, we don't know, or both of them, that will be a case of infinite interval. So we will discuss over here. These are the examples of the infinite interval. So here you can see that this is a open interval, but it is on the right hand side infinite. Here this a is not included now this time. That's why we are using strictly greater than. This means this a point is not included, but the rest of point to the right side of the a till the infinity, all those points will be included in this interval. And now here we have the half open and close interval. So this a will be a closed, and then here we will use the greater or equal sign here, because here it is the closed interval. So it will goes toward the positive infinity as well. And here now this time we are using the, here you can see that each time when we will write the infinity, either it is positive or negative, we will never use the close bracket over there, because we cannot reach to the positive infinity or the negative infinity. That's why we will use these symbol over there, these brackets over there. So I hope now this all these are understandable, that how we can write and how we can represent these interval on the number line. So here you can see that this is the whole real line actually, negative infinity and positive infinity. In between all those number will be the member of this interval. So set of all real numbers will be that. Here this will be the whole real line. Now here is the solution of inequalities, and I already shared with you few problems that how we can solve the inequalities. So I am not going to give you detailed explanation about these examples. So you have to understand and solve all these examples on your own. I hope this is not difficult, or it is easier to understand how we shift and how we are using here the rules of inequalities, and how we can represent the solution on the number lines. So all these are the important examples, but as they are not much difficult, so I hope you can solve and understand on your own these examples. And here we have your problems. You can consider these. Okay, I already solved few problems from here for you people, and you can check those videos as well. Now, what is the absolute value? Absolute value of a number x denoted by this symbol. Here we will use this symbol for the, and I told you already that absolute value in mathematics refers to a distance of a number from zero or origin on a number line, and it is always positive value, and it will be equal to, it will be, when it will be less than 0 it will be negative x, and greater than equal to 0 when it will be x. So another way you can write another definition which I already shared with you, that it will be equal to x when x is greater than 0, and negative x when less than 0, and equal to 0 when the number itself is 0, where there is no displacement. So you can consider that example, and it will give you always a positive number. So as I explained, that the absolute value in mathematics just a distance from the origin to that number. So it doesn't matter either that distance is to the right side or to the left side, but we will consider that number positive because we are doing some displacement, either if we are moving to the right side of the origin or to our right side few steps, so we are changing our position actually. So absolute value is just a distance from the origin to that specific number. So it will be always, it always refers a positive number there. Here we have absolute value properties. So you have to keep in mind all these properties. Now here we have absolute values and intervals. So if you have absolute value problem, how you will solve those problems? If you find such a problem where absolute of x is equal to some number, what is a here? Here a is any positive number actually. So you need to solve that by using these properties, that if you have such problem then you will utilize these properties, and if you have such problem strictly less than a, then you will take this x, whatever x is here, that you will write that this inequality and you will solve the problem, and so on. So you have to remember all these absolute value properties. So here you can see that here we have a example. Like now we have absolute of x is actually now equal to 7. So what is this property? Actually, this is the number 1 where here you can see that this is what actually, this is absolute of x is equal to, a. Actually, this is very difficult to write over here. So this was the property. So here you can see that this is the property. Now our question is in the form of this absolute of x is equal to 7 over here. So what we will do that to solve this kind of problem, we need to take whatever this x is. Now here x was just, we have the x, and we have taken that equal to plus minus a. We need to solve this with one time with a and second time with negative a. We need to solve this equation for both of them. So here now a is 7. So this means we need to take x, whatever x is, we will write that equal to plus minus a. So here we will have, this is now our whole x. You can consider it. This is actually, this whole is our x now. This whole is our x now. So this will be equal to 7. Plus minus 7 over here. Now this means we need to solve this equation one time with 7 and the second time with negative 7, and both will be the solution of this equation. You can find here, these are the solution. Both will satisfy this equation. If you substitute these value x as a 5 into here, you will get 7 minus 3, 10 minus 3. So that would be equal to 7. And the left hand side will be equal to right hand side. So if you substitute here 5, you will get the 7. And now for the negative 2, if you substitute here negative 2, what you will get here, again you will get a 7. So let us check that if you will, these are the solution, it must satisfy. So here if you will have 2, and then if you will take x as 7, then minus 3. So what would be that? Here 10, sorry, 14. So no. Here we will have 5, and then we have 10 minus 3. That will give you a number 7, which is on the right hand side. And now you can substitute this negative 2 in the same problem. It must satisfy the inequality because these are the solution of the equation. So here we have 2 now into, instead of x, we have this time negative 2. Now minus 3. So what will give us, this is, now you can multiply, but minus will be as it is. And here you will have 4 minus 3. So it will give you actually negative 7. When you will add these numbers, negative 7 and negative 3, it will give you a negative 7. But what we have here, actually here also we have this. This is the absolute value over here. Here we have the absolute value, and here we have the absolute value. And I told you that in mathematics, absolute value is a distance from the origin to a specific number. It doesn't matter that distance is to the left side or the right side, it will give you a distance, cannot be the negative number. It could be a 0, but cannot be a negative number. So it will give you a number 7, and this will also give you a number 7. So this means for both values of x, this equality holds. So that's why these are the solution of these inequality. This equality. Now this is not the inequality, this is equality. Now we know that when two algebraic expressions are written with the equal sign, this becomes a equation. Now here again we have another example, and here now this time you can see that here we have absolute of x is strictly less than 1. Now in this case, what does it mean? What property you will use here? Actually, this is absolute of x is strictly less than 1, and if and only if it happens when, if and only if, this is the symbol which you can use for if and only if this x lies between x is less than 1 and greater than minus 1. Now, if you remember that before we had the properties where we have seen that there was absolute of x strictly less than a if and only if x lies between a, positive a and negative a. So we will use that case, or you can say this case, this here I have written this one because of this one, but in general you have here, you can have here any arbitrary constant. So you can consider this a over here. Now this whole is your x. So you just need to substitute in here that whatever this x is, this one. So this whole is your x, this x is here. And you will write it strictly less than 1 and greater than 1. So what we are doing here, you can see that here we are using this property actually, this property, that absolute of x is strictly less than a if and only if x lies between positive a and negative a. This sixth property we are using there. So now you can write with the help of, okay, here we have written as well that this is a property 6, and now you have to solve this inequality for the value of x. This means whatever here added or subtracted or in multiplication or in division, you need to remove that and you need to simply find the value of x. So we have discussed many other problems that how you can do that. You can remove this by adding 5 throughout the inequality. If you want to add here in order to cancel out from here, this means you need to do the same operation over the right side and the left side. Throughout the inequality, you will perform the same operation. You will subtract 5 and now you will left with, now then you will multiply throughout the inequality with negative half or the negative 1 upon 2. So when I hope you remember that when we will multiply with the negative, so this means this inequality sign will reverse. So before it was strictly less than on both places, but right now you can see that after multiplying by minus half, it will be reverse. Now we have the greater than, strictly greater than, and strictly greater than over here. And there is another property for the inequalities, the rules of inequality, which we have discussed in earlier, I think in first video. So there we have discussed that this is the rule that when you will take a reciprocal on both sides, it will also reverse the inequality. So again, you will reverse it. And this will be the solution of that. And now you can write it into the interval form like this. As we have strictly less than on both places, this means that we will use the round brackets, or you can use the open interval over here. This means these two are not included in this interval. So this would be the solution of this inequality. I hope you got it. Now we have few problems. You have to solve these problems and these exercises.